So it's just one of those things where it'll always come back to haunt you. It's just one of those things in math that it's just going to come back all the time and just haunt you because it's used in a lot of things and not just for what its main purpose is, which is solving quadratic equations. All right. So that very first page of that new packet, all right, is the actual quadratic formula. All right. So typically what the quadratic formula is that if you start with ax squared plus bx plus c is equal to 0. So in other words, the standard form of a quadratic, you can solve that quadratic using this formula. And this formula works for any quadratic. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So I highlighted them. You don't have to. I just highlighted them just so you can see where these values are coming from. So the a value is from the number next to the x squared. The b value is the number next to the x. And the c value is always the constant. And again, you don't have to color yours exactly like mine. You don't even have to color it at all. It depends on just what you want to do. I don't care. Now, does anyone know what plus minus means? Plus or minus. So in other words, it literally is just at the end of quadratic formula. That's how you get two solutions out of it. You would add for one of them, subtract for the other. So the plus gives you the first solution. The minus gives you the second solution. Now, you know the formula, but now you need to know how to use it. All right. So the actual use of the formula is where a lot of people struggle. Because first off, it's just a very big formula. But it's one that you just have to know, like there's no getting around it. But using it, there's just a lot of moving parts. And you gotta be careful. All right. So how to use the quadratic formula. Here's some steps for you. So the first step is all right. So you first got to get one side equal to 0. So what I mean by that is that you need to get your original looking like ax squared plus bx plus c is equal to 0. And you do that by combining like terms. So you move things over like you would in an equation, and then you have to combine like terms. Which remember, combine like terms just means you only add the coefficients or the numbers. You don't mess with the exponents. The second step is to identify what A, B, and C are. All right. What I tell my students is always just do a quick write down of what A, B, and C are so you can just easily plug and chug. All right? You shouldn't have to think too hard about that when you're putting it in the formula. Once you identify them, then you plug into the formula. And just so you're aware, no variables in the formula, only numbers. So you will never have an X in the formula, except for that X equals on the left side, but you will never physically put X in it. Only numbers goes in that formula. If you put an X in it, it's already wrong. That, and you will make your life a living heck. All right? It should just be easy order of operation computations. Okay? Step 4, simplify wherever needed. So that can be any operations. So squaring things, making things negative, multiplying, adding and subtracting. That could also mean simplifying the radical. So we will review that as well, how to simplify a radical. Because there is a radical in the formula. It's that square root. So sometimes you have to simplify because I want exact answers, not rounded. And then you have to simplify some fractions. Because there is a fraction bar, and sometimes it doesn't compute prettily, so you would have to simplify it. And then the last step is that you would split apart the plus minus and evaluate, but you only do this if the radical is gone, meaning you no longer have a square root. All right, it either worked itself out like you had a perfect square or worked out nicely. That's when you would break apart the plus minus. If the radical's still there, you just leave it as it is after you've simplified everything to the max that you could. So that's the basic steps. All right. Now let's look at some more complex steps. Or actually, let's put it into action, I should say. So the first example on this page. So we're just going to practice right now, just putting it flat out into the formula. All right, we'll do solving with the ones on the other parts of the packet. All right. So first off, this is my original. Is it already in standard form? Meaning one side's already equal to 0. We don't have to move anything over. Is it in standard form? Yes. All right. Now, what is my A value? It's just 3. So that's A. What is my B value? 4. And what is my C value? -8. So guys, also just to note, A always goes with x squared, B always goes with x, C always goes with the constant, always. All right, so let's say, for example, you didn't have an x. Like you had an x squared and a constant, that was it. That just means the B value is 0. All right. So it's not necessarily about order. It's about which letter is going with which variables. So A always goes with x squared, B always goes with x, C always goes with a constant. All right, so if I was to put this in, what's the first thing I would put here? I'll put a 4, that's the B, but what has to happen to that B? Has to be negative. So we have -4, plus or minus, what goes with the square? 4 again, because it's B squared. -4 times what? A, which is 3, And then C, which is negative 8, all over what? 2 times 3, which is A. So again, all I did was just replace. So if I have x equals, I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So everything I wrote in black, that's just part of the formula. All right, the colors are what you are actually replacing. All right, so if it's in black, it is part of the formula. You must always include it. And I know it has it again up top, but I just wrote it again just so you guys can just see it for easier reference. Now, we're not going to solve just now. I just wanted to make sure you put it in the formula. So let's try another one with just putting it in the formula. So example 2. First off, do I have ax squared plus bx plus c equals 0? No. What do I need to do? I need to move something over to the other side. What am I moving? 20. How do I move it? You subtract it. Now, is there a like term to subtract the 22? No. So all we're going to do is slap it on at the end because it doesn't have an x or x squared, so that's our constant. So this is now 2x squared plus 5x minus 20 is equal to 0. Now we can identify a, b, and c. So what's my a value? 2. What's my b? 5. And what's my c? Negative 20. All right. So now let's put in the formula. So what do I put first? Negative 5 plus or minus the square root of what? 5 squared minus 4 what? 2 times negative 20 all over 2 times what? 2. All right. Now, the reason we are not simplifying these yet is because before we can simplify, I got to teach you guys how to, or revisit how to simplify radicals. So technically everything we're doing today, you have seen before. You saw it back in math 2. All right, or at least you should have. Not, it's okay, that's why we're reviewing it. Or if you don't remember it, that's okay, that's why we're reviewing it. So go to the next page, and let's look at this first one right here. So, when it comes to simplifying radicals, all right, it's just something that you just kind of have to know what to do. All right. So, the way you simplify a radical is, and I'll just write the steps up here. So, to simplify a radical, you first break the radicand, which is that number under the radical. So that's the radicand, into 2 factors where 1 is a perfect square. So does anyone know what perfect square numbers are? What does it mean to be a perfect square? Nope. Well, I'm not talking about the shape of a square, but that kind of does lean it down to. So think about it this way. If you took the area of a square, how do you find that? You multiply the length and the width. All right. But aren't squares the same size on all sides? So that means you're doing the same number by itself. All right. So in other words, So not divide. So you're squaring it. So you're squaring that number. So a perfect square means that you can, what does a square? Square root. So perfect square is a number that gives a perfect square root evenly. So just so you're aware, those numbers are, and I would write these down. So perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and they keep on going. So those are the perfect squares, where if you took the square roots of all of these numbers in order, you would have number 1 through 15. So if I took the square roots of all of those numbers, it would literally go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you need to be able to identify perfect squares. Is that starting to come back to you a little bit now, what perfect squares are? Okay. So once you get that, you're going to rewrite the radical as the factors. So it would look like this. So my two factors were a times b. That would be under the radical. And I can rewrite it as square root of a times the square root of b. And then finally simplify the radical with the perfect square. Now again, this may mean nothing to you right now, but we're about to do an example. All right. So first off, number 1, I have the square root of 32. We know 32 is not a perfect square. It doesn't even fall on that list of numbers that I gave you. So the first thing we're going to do is we're going to break down 32 into its factors, all right, where 1 is a perfect square. So here's kind of my strategy. If you know your perfect square numbers, I would just start dividing by all that 32 by all the perfect square numbers, and whichever one is the biggest, that's the one you want to use. All right. So obviously, where do we stop when we divide by the perfect square numbers? What numbers do we have to stop at? Like what can we not go past? So what I'm meaning is if I do 32 divided by each of these numbers, do I need to go all the way to 225? No. Where can I stop at? 25, because I can't get over 32. All right, so let's just go down the line. We know 1 will go into 32. All right, because 32 divided by 1 is just 32. All right, what about 4? What's 32 divided by 4? 8. All right, so 4 is an option. So we got 4 and 8. But remember, we want the biggest one, so we're just breaking it down into its factors. What about 9? Can 32 go evenly, or can 9 go evenly into 32? No. What about 16? Yes. 16 times what is 32? 2. What about 25? Can that go evenly? No. So I want the one with the biggest perfect square. So which one do you think I'm going to use? 16 and 2. So what I'm going to do is I'm going to rewrite this 32 using 16 times 2. So this will be the square root of 16 times 2. My rule of thumb is I usually always put the perfect square first. You don't have to, but it's easier to see. Then right here, I said that we can rewrite a radical like this to look as two different radicals. So I can rewrite this as the square root of 16 times the square root of 2. And then I need to simplify that perfect square. So I need to simplify this radical right here, because we know square root of 2 won't give us anything pretty. But what's the square root of 16? 4. So this will be 4 times square root of 2, which we could just clean up to be 4 square root 2. And that's our answer. Now, while I am teaching you how to do this by hand, because you will need that for the EOC, here's a tool that you can use to help check yourself while you're doing this. Okay? So, if you go to my Canvas page, all right, I have attached a calculator simulator in the modules. It's called a NumWorks calculator. All right, so if you go to modules, class information, do you see where it says NumWorks calculator simulator? You click on that. This is what it takes you to. Now, this is a new type of calculator. It's fairly new. You can get a physical version of it. I have one. All right, looks like this. But the simulator is free online as well. All right. The great thing about this calculator is that you're allowed to use it on the EOC if you have one, a physical one. You're allowed to use it on ACT. You're allowed to use it on SAT. Any of those standardized tests you can use. Now, what's the difference between this and a TI? This one simplifies radicals for you. So, TIs don't do that. They give you the decimal, ugly decimal version. But, so if I hit full screen, all right, first you want to go to calculations. So you hit enter. We're okay. Let's type in that exact same radical that I just did. So I'm going to type in square root of 32. I'm going to hit enter. Didn't we just get what we just got? So, now in this class, I do not mind if you use this, even on tests. All right, if you want to pull the simulation on the test, that's fine. But what I'm saying is you still need to learn how to do it by hand, because, all right, unless you have the physical version of this, you won't have access to it on the EOC unless you have the physical version of the calculator. Which, by the way, that calculator is actually cheaper than a TI by about 20, 30 bucks. It's called a NumWorks. So if you want to learn more about that, just come see me. But this is attached in Canvas. You can hit that link. It'll open up the simulators in modules under class info. It's just a good way to check yourself. Okay? So that's what we're going to do as we simplify these radicals. We're going to put it in NumWorks just to check ourselves. All right? So let's do another one together. So 128. So we got the square root of 128. So first thing we're going to do is we're going to break it down into its factors using perfect squares. So we know 128 divided by 1, that works. Can 128 be divided by 4 evenly? Yes. What is it? So 128 divided by 4 is what? 32. Good. All right. What about 9? Does that work? So if you do 128 divided by 9, do you get a nice pretty number? No. What about 16? 8. So we got 16 and 8. What about 25? Does that work? No. 36? Does that work? You guys can put this in your calculator. Just do 120 divided by 36. Do you get a nice pretty number? No. What about 49? No. 64? You get 2. Now, since we got something times 2, we're going to stop right there because we can't break it down any further. Because the next breakdown further would be 128 and 1. So, which one has my biggest perfect square? 64 and 2. So So we're going to rewrite that radical as 64 times 2. I'm then going to break it apart to be 64 times the square root of 2. All right, what's the square root of 64? 8. So we got 8 times square root of 2. So my answer is 8 square root 2. Is this making sense for you guys, like what I'm doing? Okay. So now let's check it in my numwork, see if I'm right. So I'm going to type in the square root of 128, and I get 8 square root 2.
On the test, if it was like set up like that and we did like through the calculator, would you write it wrong if you didn't like write it down and you just wrote the answer?
No, because I said that you can use that in my classroom. Now, what I'm saying is that you still need to practice it by hand because unless you have the physical calculator, you won't have this on the EOC.
Okay.
All right. I'm just saying that this is a good checking tool.
Yeah, I was just asking.
Yeah. All right. Now, that's when we have a positive under the radical. But sometimes we end up with a negative under a radical. Does anyone remember what you do when you have a negative under the radical? Because technically, if you put the square root of negative 200 in your calculator right now, what would it say? Error. It says error. Specifically, what does it say? Error next to it. Does it say syntax, domain? What does it say?
Not real.
It says not real because it's not a real number. All right, it doesn't exist. Well, it is an imaginary number. It's just not in the real number family. All right. So, yes, there are imaginary numbers. All right. So, does anyone remember what I do? We still simplify the 200 like we've been doing. All right. But what do you think I have to do with that negative? Take an I out. Good. So just to recall, the square root of negative 1 is I. Now I write my I's in cursive just because when I do this, just so I don't accidentally think it's a 1 or something. You don't have to. You can just write it like a print I. So what I have to do first is to get rid of this negative. I'm going to rewrite this as I square root of 200. So the I has to come out. And the I always goes to the left of the radical. All right, don't write it on the right. Now I can break down 200 like we've been doing. So take a guess. What do you think would be the biggest perfect square number that would go into 200 nicely? 100. All right. So you can still do the whole guess and check thing, but 200 is one of those nice ones where you can just eyeball it and know. So it's 100 times 2. So how would I rewrite it? So I have the I. What goes back under the radical? 102. What do I do next? So I still got the I separated. So I got 100 times the square root of 2. What's the last thing I got to do? Square root what? 100. What's the square root of 100? It's 10. Guys, please stop talking. So this would be 10I. Boys, stop talking. 10I times the square root of 2, which we can rewrite as 10I square root 2. Now, if you wrote the I on the other side of the 10, I wouldn't count it wrong, but just know that typically the I goes like, it's almost like it's the variable. You know, how if you write multiplication with variables, it would go on the right side of the number. But if you wrote it on the left, I wouldn't count it wrong. It's just awkward. All right. Now, let's just check to make sure. Yes, ma'am. Yeah. let's just make sure that we did the square root of 200 correctly. So I'm going to put in my numworks just to check. So I'm going to type in the square root of 200. Now, if you type in negative 200, this will not give you the I. All right? So just know that with negatives, you got to take the I out. We got 10 square root 2, and then we just had to include the I. All right? Calculators cannot calculate imaginary numbers. You got to do that stuff by hand. All right, so take a minute. Try number 4 on your own. So start by dividing it by perfect squares. See which one you get that's the biggest. Now, if you want to check yourself and see if you're right, once you think you got an answer, you can always pull up that number and calculate on your problem if you want to. Yes. So which one is which one the old one is? Oh, there. That's why I said divide by your perfect squares, so you don't have to worry about it. Yeah, because you can honestly, because there will be some that just neither of them are squares, so why not solve it right now? All right, thumbs up if you're ready. All right. Go ahead and share, compare answers with groups. Good job. I already have it done. I have it written down. I just haven't put anything in the frame. All right, so let's start with Davis. What's my first step for evaluating this? All right, so when I break it down, before I even do that, what should I do? Or I need to take care of this negative first. So what do I need to do first? What did I do up here with the negative? I took in Davis, look at me. I took in the I out. There you go. So this would be I square root 54. All right, now we can break it down. So what two numbers did you get to break down into where one of them is a perfect square and the highest perfect square? Let's go, Lanaya. Good, 9 and 6. So if you went down the line of all your perfect squares, you can replace it with 9 and 6. So I would rewrite this as the square root, I square root of 9 times 6. What do I do next? David. Split the radicals up. So this would be I square root 9 times the square root of 6. And then we just got to simplify the perfect square. So what's the square root of 9? 3. So this would be 3I square root 6. Now, just to be safe, let's test the square root of 54 and make sure we get 3 square root of 6. Because we know we got to take an I out anyway. But I just want to make sure we got the radical right. So I got the square root of 54, 3 square root 6. So we're good. Yes, ma'am. It should.
I can figure it out after.
Is it saying it's blocked or
It's sends me here.
hit full screen?
I got it. Thank you.
So technically, like that little picture, it actually is the calculator, but it's hard to see, so you just have to hit full screen.
Oh, okay.
Yeah.
I was like,
All right, now since we got a pretty good understanding about simplifying radicals, let's do some quadratic formula. So just again for reference, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So first things first, number 5. Do I have it to where I have it in standard form where one side's equal to 0? No. So what do I got to do? Add the 3 over. This will be 9d squared plus 12d plus 4 is equal to 0. Boys. Now I got it to where I can identify my A, B, and C before I put it into my formula. So what's A? 9. B? C. Good. Now, all right, now I'm going to put it into my formula. So I have x equals, what comes first? Negative 12. Because remember, the negative is part of the formula, so we got to change it. Plus or minus the square root of what? 12 squared minus 4 times 9 times 4 all over 2 times what? 9. Now, I have done absolutely no simplifying. All right. I just plugged it into the formula. So that's my suggestion to you. Do not simplify until after you put it fully in the formula. All right. Don't do any simplifying when you initially put in the formula. Because if you just try to simplify right off the bat, it's going to get messy and you may get it wrong. All right. So if I start simplifying, though, I typically like to start simplifying under the radical. So what I typically do is I do the square on its own, and then I multiply the negative 4 times 9 times 4 on its own, and then I bring them back together. So I got negative 12 plus or minus the square root of, what's 12 squared? 144. Now, what's negative 4 times 9 times 4? So you can put that in your calculator, guys. Negative 4 times 9 times 4. What is that? It's negative what? 144. All over, And then what's 2 times 9? 18. Now, I'm still in simplifying the radical land. So I do the addition subtraction. That'll end up being under the radical. And what's 144 minus 144? 0. So I got x is equal to negative 12 plus or minus the square root of 0 all over 18. What's the square root of 0? 0. So x is equal to negative 12 plus or minus 0 over 18. Now, the radical is gone. So that means that we can break it apart, that plus and minus. So I have negative 12 plus 0 over 18, negative 12 minus 0 over 18. Now, let's be honest here. If you add or subtract 0, won't it pretty much be the same? Yeah. So we're actually going to end up getting the same answer for this one, which is pretty rare. Because what's negative 12 plus or minus 0? So what's negative 12 plus 0? Negative 12 was negative 12 minus 0. Still negative 12. So I have negative 12 over 18. And now I just got to simplify that fraction. So if I simplify that fraction, what would it be? So x would equal what? Lower. So negative 2 over 3. You can divide both of these by 6. Now, if you're not the best at simplifying fractions, you can always, in your TI, you can always put in 2 divided by 3. Not 2 divided by 3. You can always do negative 12 divided by 18 and then do this as soon as it loads up. So I can do negative 12 divided by 18. And then I can hit the math key, which is right below that green alpha key. See how it says frac? I can then hit enter, enter. There's my simplified fraction. You can also do the same thing in Desmos. So my answer is x is equal to negative 2/3. Any questions on that one? So that was one where we had a rational answer, meaning that the square root got gone. All right, let's look at another one. Let's look at number 8. So first, we got to make sure that one side's equal to 0. Is it equal to 0? No, so what do I need to move? We got to subtract the 6 to both sides. So this would be 3z squared minus 7z. Then what's 3 minus 6? Negative 3 is equal to 0. All right. Now I got to where I can label A, B, C. So what's my A value? 3. B, C. Negative 3. Now I can put it in the formula. So I have x equals negative what? So a negative times what? Negative 7. Yeah, so guys, since that negative is in the formula originally, we still got to multiply it even if the number's already negative. So it's a negative times negative 7. So what's going to happen is going to make it positive. But for right now, I'm not simplifying anything. Plus or minus the square root of what? Negative 7 squared minus what? 4 times, good, all over 2 times what? 3. All right, so now I'm going to simplify all I can simplify. So that what's a negative times a negative? Positive. So I have positive 7 plus or minus the square root. What's negative 7 squared? Not negative 49, positive 49. Now, what's negative 4 times 3 times negative 3? Positive 36. So we do plus 36, not minus anymore. All over what? 6. 2 times 3, 6. All right. Now we're going to simplify what's under the radical. So I have 7 plus or minus. What's 49 plus 36? 85. All over 6. Now, here's my question to you guys. 85 is clearly not a perfect square. But if I divide it by my perfect squares, so by perfect square numbers that I know, do you think any of them will go in evenly into 85? It's like if you divide by 1, if you divide by 4, by 9, by 16, 25, etc. Will any of them work? No, they won't. So if the radical doesn't simplify, you just got to make sure that all the fractions are simplified, meaning there's an unspoken 1 here. So you have to make sure that like all 3 of these numbers, they can't be simplified. So 7 over 6 and 1 over 6 doesn't simplify. So since they can't, our final answer is 7 plus or minus square root of 85 over 6 equals x. And remember, that technically is 2 answers, because if I split this apart, this would be 7 plus square root of 85 over 6, 7 minus square root of 85 over 6. So all I did was plus or minus it. I broke apart that plus or minus, so I have 2 roots. But you can leave it with just the plus or minus. That's fine with me. All right, just be careful because sometimes Delta Math is picky and they actually want you to break it apart. But this would actually be our final answer. It's an irrational number. Meaning, if we put it in the calculator, it would be like some really funky decimal. So the radical doesn't always simplify. So sometimes it does, sometimes it doesn't. If it doesn't, you just leave it as is. Now, let's try one where the radical will simplify. So let's look at number 10. All right, so number 10, first off, is it in the form that it needs to be before I can put it in the formula? No, so what do? Add 3 to both sides. I'm adding it to that 2 because it's both constants. So I have 5k squared plus 12k plus 5 is equal to 0. Now, I can now identify my A, B, and C. What's my A? 5, B, C. Good. So now I'm going to put it into the formula. So I have x equals negative what? 5 plus or minus the square root of what? 5 squared minus 4 times what? 5 and 5. All over oh, it's not 5, it's 12. Yeah. That's 12. I thought that looked wrong. Over if my pen will stop being stupid, 2 times 5. Yes. Huh? No. Yes. Yes. See, that can happen, all right? So make sure you are keeping your values consistent. So B is first, all right? Now, so let's do some simplifying. So we get x equals negative 12 plus or minus the square root. What's 12 squared? 144. What's negative 4 times 5 times 5? Negative 100. All over, what's 2 times 5? 10. Simplify under that operation under the radical a little bit. I get negative 12 plus or minus the square root of what? 44 all over 10. Now, 44, square root of 44 will potentially simplify. So we're going to simplify that radical off to the side. So if you divide 44 by all your perfect squares, which one is most likely to work and be the highest? So take a minute, find the set of factors where one of them is the perfect square, and I want the biggest one. So if you get it, don't say it out loud. All right, anyone got it? What is it? 4 and 11. Good. 4 being the perfect square. So if I rewrite this as 4 times 11, so square root of 4 times the square root of 11, what would it be simplified? 2 square root 11. Good. Let's check in numworks real quick. I have square root of 44. I do indeed get 2 square root 11. Oh, and just so you know, if I put in the one from the previous question, so square root of 85, notice how it doesn't even give us a simplified version, it just gives us a decimal. That means it's in its simplified version. So I'm going to replace the 144 with this 2 square root 11. So this would be negative 12 plus or minus 2 times the square root 11 all over 10. Now, the radical simplifies. So the last thing we got to check to make sure it's simplified is all the fractions. So here's my rule of thumb. All three numbers that are not under the radical need to, if they can be divided by a same common factor, that's how you simplify. If they can't, you leave it alone. It has to be all three of those numbers. All right, and if there's nothing in front of the radical, it's 1, so that automatically says you're done. So what common factor would go into negative 12, 2, and 10? 2. So I'm going to divide all of those by 2. So that means x equals, what's negative 12 divided by 2? Negative 6 plus or minus. What's 2 divided by 2? 1. Still have the square root of 11. You don't touch that. What's 2 divided by 5? 5. And now I'm done. So just to clean it up a little bit, x is equal to negative 6 plus or minus square root of 11, because you don't have to put the 1, over 5. If you left the 1, I wouldn't count it wrong, but you just don't have to. Any questions? All right, now that we've done a lot of practice, try number 12. I want you to be nice as well. Negative in the formula, which means that whenever the formula is negative, you gotta still test it. That's why they're big on the front. So guys, we'll give you a hand on this one. Don't be phased if the number of your rep is negative. Oh my God, it's not like directly towards you.
Oh.
It's over the brace. There's like 15 hours left. The squares. I didn't know it was It's not. So, negatively. If you want to standard form, that'd be yes, please. Yeah. Okay, in your calculator, did you put the negative thing in parentheses?
Oh, I was afraid out of that. I don't send people in short.
Just that equals minus that, right? Because the negative goes with. Oh. Yeah. Six.
Jonathan, what the
Yes. All right, guys, I'm gonna give you one more minute, and we're gonna go over it. So if you're done already, share it with the group.
I have no idea how you help. Well, I'm just using the Quadratic. But I got 7 plus and
All right, my darlings, let's talk about it. So, I gave you this one because I knew there would be a couple of missteps in here, and I did see them. So, what's my first step? Minus 28 to both sides. 28x. Now, that negative 28x is going to go between these two numbers because remember, I want it to be ax squared plus bx plus c. All right, so the x value has to go in between the x squared and the constant. So this will be 4x squared minus 28x plus 61 is equal to 0. Yes, sir. Yeah. So A, B, and C. What's my A? 4. B, stop talking. Negative 28. C, 61. So if you put in the formula, I have negative times negative 28 plus or minus the square root of negative 28 squared minus 4 times 61 all over 2 times 4. Did everyone get that far? All right, now what happens to the two negatives right here? They cancel out, become positive. This is positive 28 plus or minus. Now, this is the misstep I saw a lot. What's negative 28 squared? Positive 784. So, here's the thing. Here's how I know that a lot of people made this mistake. So, in your calculator, if you type in negative 28 squared, just like that, it's going to give you a negative 784. But that's because your calculator is reading it as 28 squared times negative 1. All right. How it should be if you want to square a negative number is you got to put the negative number in parentheses. So your calculator knows, okay, that negative has to stay with the 28. All right. Because trust me, calculators, they're not complete geniuses. They can be a little stupid sometimes. And that's where they can be a little stupid. All right. So just remember, if that number is negative, just go ahead and put it in parentheses so you don't forget to put that in your calculator. And then what's the second number? So negative 4 times 61. 976. All over 8. So this would be 28 plus or minus the square root of negative, 192? All over 8. Now, 192 can most likely simplify. So, first off, since there's a negative under that radical, what's the very first thing I got to do, hands down? Take that I out. Now I can break down 192. So remember, because I saw some people stop at, because it can go into 16. So 16 times something gives you that. 16 times 12. But the problem is 12 still has the perfect square in it. That's why I tell you keep dividing until you can't really go past anything. So what is the largest perfect square that 192 can be divided by? So what's the largest perfect square number that can be divided by? 64. That's why I say keep going until you can't get anything further out of it, because you want the largest perfect square so you don't have to do it multiple times. Because what will happen is if you do a smaller perfect square, you'd end up having to break down the radical again. All right, and you just want to have a one and done. All right, so it'd be 64 times 3. This would be the square root of 64 times 3. So square root of 64 with the square root of 3. What's square root of 64? 8. Square root 3. And remember, the I is still going to be in there. So this would be 28 plus or minus 8I square root 3 all over 8. Now, my last step is to make sure that these fractions simplify. So is there a number that can go evenly into 28 and both of those 8s? 4. So 28 divided by 4 is 7, plus or minus 8 divided by 4 is 2. Still keep the I and the square root of 3. All over 2. Now, even though 2 and 2 can go into each other because of that 7, we're not going to go any further. So this is my answer. How'd you guys do? Okay? Yeah. All right. So that's it for today. So your homework, it's a very short delta math. It's only 6 problems. All right? But it is all quadratic formula. Yes, ma'am. Not the quizzes. But if you did finish the quizzes, just shoot me an email. I'll look at it. Shoot me an email so I will remember to check it.
You know the delta math for like before 3.
Yeah, I saw your email. I just haven't. I've been grading tests today. It'll be done by Monday.
I was just wondering if like
Oh yeah, it's gonna be uploaded. I just haven't done the massive regrade yet.
So I don't want this to sound stupid, but I just want to make sure. So every time this is negative, an I is going to be pulled out of it.
Every time. Okay. So in other words, here's how I remember it. It's really stupid.
Okay.
If the radical's being negative, that means we want to fight, and we're gonna take its I out.
Oh, I like that. It's kind of like how I learned PEMDAS. Like the.
Please excuse my dear Aunt Sally.
Yeah.
Hey guys, so here's a little thing to remember about negative radicals with I. So, if the radical's being negative, that means we want to fight them, and we're going to take their I out. That's how you can remember it. It's really graphic, but it works. All right, so you guys have a solid 15-ish minutes to start on that delta math.